All right, guys, we're back for part two of the study guide. Sorry about that. So these are numbers 6 through 12. And our first question says, how many moles are in 57.34 liters of krypton? So, like always, we need to write our known 57.34 liters of krypton and our unknown, how many moles of krypton. Start with our known and put it over 1. Now we're going from liters to moles. So let's check our conversion chart. Notice I have a different one. Liters are up here in volume to moles in the center. So I'm going to multiply by 1 mole times 22.4 liters. When I multiply that out, you should get an answer of 2.56 moles of krypton. These units cancel out. Number 7, our first two-step problem. We have calculate the number of grams in 4.22 times 10 to the 23rd atoms of uranium. So my known my unknown, okay. Now I'm going to put my known over 1, just like always. Looking at our roadmap, we have particles, and we need to go to moles, and then we need to go to grams. So our first one, we're going to multiply by 1 mole over 6.02 times 10 to the 23rd particles. That's our first step. So we're right here now. Now we need to go from moles to mass. So we're going to multiply by molar mass over 1 mole. The molar mass of uranium, when you look it up on the periodic table, is 238.03 grams. Now, this unit and this unit will cancel out, and atoms will cancel out. Then I'm going to do my math. Remember, you need to put parentheses here in your calculator, or else you will not get the correct answer. When you take all of that math and do it, you're going to get an answer of 166.86 grams of uranium. For number 8, we have how many formula units are in 621 grams of NaCl? Known, 621 grams NaCl. Unknown, question mark, formula units of NaCl. Okay, take our known and put it over 1. Now I'm going to check my roadmap, and I want to go from grams to formula units. So I'm going to start here, grams. Then I'm going to multiply by 1 mole over the molar mass to get to moles. The molar mass of NaCl, when we look it up on the periodic table, we have Na plus, times 1 plus 1 chlorine. So that ends up being 58.45 grams of NaCl. Then I need to go to formula units. So I'm right here at the mole, and I need to go to formula units, which is particles. So I need to multiply by 6.02 times 10 to the 23rd particles over 1 mole. Sorry, that's 23. Do not forget to write all of these units. Okay? Grams of NaCl is going to cancel out, and then moles of NaCl is going to cancel out. So I have 621 divided by 58.45 multiplied by 6.02 times 10 to the 23rd. When you multiply all of that out, you should get 6.39 times 10 to the 24th. And our units are formula units of NaCl. If you need to write any of those down, go ahead and pause the video. I'm going to erase them. For number 9, we've calculated the volume of 8.65 times 10 to the 25th molecules of argon at standard temperature and pressure. Our known is whatever number we're given, 8.65 times 10 to the 25th, and that's molecules of argon. I don't know why I wrote that G, but it's staying there. Unknown, how many liters of argon. Okay, so let's take our known and put it over 1. Using our chart, we need to get from molecules to volume. Here's molecules. So I know I'm going to multiply by 1 mole over our number of particles. And then I'm going to multiply by 22.4 liters over 1 mole. My units are going to cancel. So I'm going to be left with liters of argon. And after I do all of that math, you should get 3,218.60 liters of argon. For number 10, we have how many molecules of SO2 are in 674.58 liters of sulfur dioxide. So our known 674.58 liters of sulfur dioxide. Our unknown question mark molecules. Start with our known over 1. So we're going from liters to molecules. Liters is up here. We need to go down. So we're going to multiply by 1 mole over 22.4. Then we're going to go to molecules, which is particles, and we're going to multiply by Avogadro's number over 1 mole. Our units are going to cancel out as long as there's one on top and one on bottom. So we're going to be left with molecules of SO2. After all of that math in your calculator, you should get 1.81 times 10 to the 25th molecules SO2. If you need to write those down, go ahead and take a minute. I'm going to clear that. We have number 11 and 12 left. For number 11, how many grams of ammonia is 76.8 liters at standard temperature and pressure? So my known, 76.8 liters of NH3. Sorry. My unknown, question mark, grams of NH3. Start with my known, put it over 1. No, I'm going from liters to grams. Look at my conversion. Liters is up here. Grams is here. So I need to multiply by 1 mole over 22.4 to get to moles. And then I'm going to multiply by the molar mass over 1 mole. To get the molar mass, remember we look at the periodic table. So we add nitrogen, which is 14.01, plus our 3 hydrogens, which should be 3.03. So we end up with 17.04 grams for the molar mass. Looking at my units, if it's on top and bottom, it's going to cancel out. And then we just need to do the math in our calculator. Once we put it in, we have 58.42 grams of NH3. Very last problem. How many liters is 1.20 grams of N2? My known, 1.20 grams of N2. My unknown, question mark, liters. Okay. So I'm going to start with 1.20 grams of N2 over 1. Look at my chart in order to figure out where we're going and where we're going to. So we're going from grams to liters. Grams is right here, liters is up here. So I need to multiply by 1 mole over the molar mass, and then I'm going to multiply by 22.4 over 1 mole. The molar mass for N2 is 14.01 times 2 to get 28.02 grams of N2. is equal to 1 mole of N2. And then always 22.4 liters is equal to 1 mole. Looking at my units, grams are going to cancel, moles are going to cancel. I'm going to be left with liters of N2, which is exactly what I want. Then I have to do the math. Once the math is done, you should get 0.96 liters of N2. That's all for this study guide. If you guys have any questions, you know where to find me. I'm always online, either on Hangouts or Gmail. Have a wonderful day. I will talk to you soon.